Example 2. So for the function f of x equals x squared over x squared minus 4, we want to basically do everything we've done before. So find our critical numbers, find the open intervals where the function's increasing, decreasing. But now we're also going to use the first derivative test to find the relative extrema for this function. And again, if there are none, we're going to state that. So for the first part, well, we've got to find our domain. So that's always going to be your first step. Find the domain. So in this case, set x squared minus 4 equal to 0. And you get your domain negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. All right, so to find critical numbers now, so we need f prime of x. Using the quotient rule, which you should work through, you end up finding that f prime of x is negative 8x over x squared minus 4 squared. So then from here, what do we need to consider to find critical numbers? So part A, critical numbers. We need to find where f prime is undefined, or where f prime of x equals 0. So f prime of x undefined means our denominator equals 0, so x squared minus 4 squared equals 0. So then solving that, you get x equals plus or minus 2. Again, you should work that out. Well, let's go ahead and work it out. So that gives you x squared minus 4 equals 0, difference of squares, x minus 2, x plus 2 equals 0, x minus 2 equals 0, x plus 2 equals 0, so x equals 2, x equals negative 2. But in this case, neither one of those are in our domain, right? So they can't be critical numbers. So now we look at where f prime of x equals 0. Well, it's equal to 0 whenever the numerator, so negative 8x equals 0. So then x equals 0 is our only critical number. All right. So then from here, part B, now we want to find the open intervals where it's increasing and decreasing. So drawing our number line, so we're restricted by our domain first off, so negative infinity to negative 2, negative 2 to 2, positive 2 to infinity. But then we also plot in our critical point here, so 0. So then that tells us our intervals are going to be negative infinity to negative 2, negative 2 to 0, 0 to 2, 2 to infinity. Next thing we need to do, we need to pick a test point in each of these intervals. So negative infinity to 0, or sorry, negative infinity to negative 2, let's pick negative 3. Negative 2 to 0, let's pick negative 1 because that's a nice easy number. Similarly, we're going to pick 1 and then 3. Remember, you can pick any values you want for these. All right, so then now we're just evaluating. So f prime of x we know was negative 8x over x squared minus 4 quantity squared. So f prime of negative 3, so that's negative 8 times negative 3 over negative 3 squared minus 4 quantity squared. So negative 8 times negative 3, that's going to be positive. Something squared in the denominator, so negative 3 squared minus 4. Quantity squared, so it's blah squared, so that's going to be positive. So that means that our derivative is going to be greater than 0 here. So f is increasing. F prime of negative 1. So we have negative 8 times negative 1 over negative 1 squared minus 4 quantity squared. So negative 8 times negative 1 is positive. Negative 1 squared minus 4 squared, since it's something squared, positive, greater than 0. So f is increasing on that interval. on the interval 0 to 2 now. So we picked 1, x equals 1 for our test point. So f prime of 1, so that's negative 8 times 1 over 1 squared minus 4 quantity squared. So negative 8 times 1, that's going to be negative. The bottom still something squared positive. So now we are less than 0, which means f is decreasing. And then 3, so f prime of 3. So that's negative 8 times 3 over 3 squared minus 4 quantity squared. So negative times positive is going to give us negative. And then blah squared is going to be positive. So negative divided by a positive is going to be less than 0. So f is decreasing on this interval as well. So now we know, combining all of that, so for part B, f is increasing on, in this case, negative infinity to negative 2, union 2 to 0, and it's decreasing on 0 to 2, union 2 to infinity. Now, I'm sure you're probably wondering, can I rewrite this as negative infinity to 0 and 0 to infinity? No, because remember, you always have to start with your domain. So, because the values at negative 2 and 2 are not defined, we still can't combine those into one interval, even though we have negative 2 in there, and it's still going to be something going on there. So in this case, what's happening, we have a vertical asymptote at negative 2 and 2. All right, so then for part C, so using the first derivative test, all the first derivative test is looking for is a sign change at the critical number. So the function's changing from increasing to decreasing at that critical number. So if we look, our critical number was 0. So if we look between the two intervals involving 0, it's changing from increasing to decreasing. So if it's going from increasing to decreasing, remember that means that f has a relative maximum there. So f has a relative max at 0, and then plug 0 into the original function. So it's at 0, f of 0, which then in this case is 0, 0. And then f has no relative minimum because we had no other critical points. If you're having trouble picturing what's going on here, just remember, you can always draw arrows. So it's going up where it's increasing. So it's increasing negative infinity to negative 2. It's going up. Remember, this is our critical number. And then 0 to 2, it's going down. And 2 to infinity, it's decreasing. So then if you kind of look, you can kind of see at that value. So looking at 0, what's going on there. You kind of see that peak for that relative maximum. All right, let's look at a radical function now. So f of x equals x plus 5 to the 2/3 power. So same idea, we're trying to find the critical numbers, the intervals where the function is decreasing and increasing, and all relative extrema. And if there are none, we're stating that. So same idea. So f of x equals x plus 5 to the 2/3 power. So first thing to consider is the what? That's right. You want to consider your domain. So in this case, our domain is negative infinity to infinity. Why is that? That's right. Remember, since our denominator of our exponent is 3, that means we're dealing with a cube root, right? And so the cube root, we have no domain restrictions to worry about for the most part. So domain is negative infinity to infinity since we have a cube root. All right, so critical numbers, we need the derivative. F prime of x is going to be equal to 2/3 x plus 5 to the negative 1/3 times 1, right? Remember, you're using the chain rule here because it's blah to the 2/3 power. And so that's equal to 2 over 3 times x plus 5 to the 1/3 power, which then is just 2 over 3, since our numerator of our exponent is 1, so go ahead and rewrite it in radical form. So 2 over 3 cube roots of x plus 5. So if we think about it, so now to find our critical values, right? So f prime undefined. So f prime is going to be undefined whenever our denominator is equal to 0. So 3 cube roots of x plus 5 equal to 0. Divide by 3 on both sides. So cube root of x plus 5 equals 0. Cube both sides. So x plus 5 equals 0. So x equals -5. Is our critical number from that part. But we still have to consider where f prime equals 0. Well, that's going to be whenever 2 equals 0. That doesn't make sense, so nothing there. So our only critical number is x equals -5. Part B, we're testing our intervals. So draw out our number line. We started with our domain, -infinity to infinity. Throw in our critical numbers as a point to break it up, so -5. So that means our intervals are going to be -infinity to -5 and -5 to infinity. We only have 2 this time. Our test points. So on -infinity to -5, let's choose -6. -5 to infinity, 0, because 0 is always an easy number to substitute in if you can. So remember, f prime of x is 2 over 3 cube roots of x plus 5. So f prime of -6, 2 over 3 cube roots of -6 plus 5. So getting our signs. So 2 is positive, 3 is positive, cube root of -6 plus 5, so -6 plus 5 is going to be negative, so cube root of a negative is a negative, so we have positive over positive times a negative, which then, well, that means the denominator is going to be negative, so we have something that's less than 0. So f is decreasing. F prime of 0, so that's 2 over 3 cube roots of 0 plus 5. So 2 is still positive, 3 is positive, and 0 plus 5, cube root of that's going to be positive. So this is all greater than 0, so f is increasing. So we know now our open intervals. So f is decreasing on -infinity to -5, and it's increasing on -5 to infinity. And so then, where do we find our extremum? So for part C, so we know because it's going from decreasing to increasing. And again, if you're struggling seeing that, draw your arrows in. But it's going from decreasing to increasing, so it has a relative minimum at -5 f of -5, which in this case is equal to -5 comma. So to find f of -5, remember you're plugging into the original function. So f of -5 is -5 plus 5 to the 2/3 power, which is 0 to the 2/3 power, or 0. So at -5, 0, we have a relative minimum, and f has no relative maximum because we have no other sign changes and no other critical values. Remember, it can only have a relative extrema at a critical number. Okay, so let's look at one more example. So f of x equals x to the fourth plus 4x cubed. So remember, the first step to do is find your domain of the function. In this case, we know our domain is going to be negative infinity to infinity since it's a polynomial. So part A, find the critical numbers. So f prime of x is 4x cubed plus 12x squared. So then that's equal to 4x squared times x plus 3 when we factor out. So we know f prime, so we need to find where f prime is undefined, but in this case we know f prime of x is defined on negative infinity to infinity since it's a polynomial. And so f prime of x equals 0 then, it's the other piece, means that 4x squared plus, or times, sorry. So 4x squared times x plus 3 equals 0. So that means 4x squared equals 0, gives us x equals 0. And then x plus 3 equals 0, which gives us x equals negative 3. So these are our two critical numbers. So then we test our numbers. So that's part B, test the numbers to find the intervals. So we know then, so our intervals, so then they're going to be, if we draw our number line out, so we start with our domain negative infinity to infinity, cut it up at our critical numbers, negative 3 and 0. So we end up with the intervals negative infinity to negative 3, negative 3 to 0, and 0 to infinity. And so then from here, so we pick a test point in each interval. So negative infinity to negative 3, let's say negative 4. Negative 3 to 0, let's say negative 1. 0 to infinity, pick 1. Again, remember you can pick any value you want to. So f prime of x we know is 4x cubed plus 12x squared. Or sorry, if we use the factored form, 4x squared times x plus 3. Make it a little bit easier to get the signs. So f prime of negative 4 is going to be 4 times negative 4 squared times negative 4 plus 3. So we know that 4 is positive. Negative 4 squared is going to be positive. Negative 4 plus 3 is going to be negative. And so that tells us it's less than 0. The derivative is less than 0. So f is decreasing. Next one, so f prime of negative 1 is our next test value. So that's 4 times negative 1 squared times negative 1 plus 3. So 4 is positive, negative 1 squared is positive, negative 1 plus 3 is going to be positive. So we have positive times positive times positive, so our derivative is going to be greater than 0. So that tells us f is increasing. And then from 0 to infinity, our test point was 1, so f prime of 1 is going to be 4 times 1 squared times 1 plus 3. So that is positive times positive, since 1 squared is positive, times 1 plus 3 is 4, is going to be positive. So we end up with a value of the derivative greater than 0, which again tells us f is increasing. So we know now for the intervals, so f is increasing on negative 3 to infinity. So in this case, we can say negative 3 to infinity because 0 is in our domain and it's not changing sign there. So it's still going to be increasing there. Now that doesn't mean there may not be something else going on there later that we'll talk about. But right now we just know, okay, the function's increasing all the way through 0. Since 0 is in the domain of the function, it was just a critical number. So f is increasing on negative 3 to infinity, and it's decreasing on negative infinity to negative 3. And so what does that mean for our extrema? So we know it's going from decreasing to increasing at negative x equaling negative 3. So f has a relative minimum there. So f has a relative min at negative 3 f of negative 3, which then is equal to, so remember you always have to have both parts of the ordered pair, so negative 3, negative 27 when we work it out. Remember, you're plugging that into the original, right? So the way we got that, so f of negative 3 was negative 3 to the 4th power plus 4 times negative 3 to the 3rd power. So that's where that came from, to be negative 27. And then, well, from 0 to infinity, f was still increasing, so we didn't have another sign change. There wasn't another change in behavior. So there is no extrema at 0, so there has no relative minimum. Sorry, no relative maximum. So remember, the critical numbers are just candidates for relative extrema. It does not mean that there's going to be a relative extrema at every single critical number. This polynomial, for example, had 2 critical numbers. We had x equaling 0, x equaling negative 3 as critical numbers, but only one of those critical numbers was a relative minimum.